Zealand, it's much the same. Now, we'll just put climate warming to the side for a moment. Carbon dioxide goes into the atmosphere, but it also goes into the oceans. And if you add carbon dioxide in water, you get carbonic acid. And these are measurements of carbon dioxide in the oceans, and these are pH measurements, and that's North Atlantic, Hawaii and Bermuda. And basically, pH has decreased by 0.1 of a unit over the second half of the 20th century, and it's predicted to go down by 0.3 of a pH unit this century, which will be unprecedented ocean change in over the 20 million years. And why this is important, coral shells are made of calcium carbonate, gets more acidic, they disintegrate, and plankton with these shells are basis of the ocean food chain. So this may damage the whole food chain in the ocean, and this is regardless of global warming. So having too much carbon dioxide is probably going to change life as we know it. Now, where are we today? Well, we are basically the Y junction for the future. This is, we're at 2010, so we're looking at about 30 gigatons of carbon dioxide emitted at the moment. If we have rapid development of new technology and halving of greenhouse gas emissions by 2050, we might add 1,000 gigatons of carbon dioxide into the atmosphere. That's over the 300-year period. If that is the case, you're able to limit warming somewhere in the range of 2 degrees. If, on the other hand, business as usual, increased use of fossil fuels, this keeps going up, and temperatures keep increasing. So Tim Flannery, head of the Australian Climate Commission, when he reported to the Australian government, said, "This is the critical decade. Decisions we make from now to 2020 will determine the severity of climate change our children and grandchildren experience." So we've got time, but it's a bit like you planning for your retirement. We're basically at 50, and you're retiring at 65. So you've got to, in a sense, save a lot or make rapid progress towards reducing greenhouse gas emissions. If we'd started earlier, it would have been easier. Now, at the moment, the picture isn't all this bright. The open circles are estimates from BP of fossil fuel carbon dioxide emissions in gigatons of carbon per year. The black dots are from the US Environmental Protection Agency. You can see here, then here's the recession in 2009, but we've bounced back up. So it's not looking that great at the moment in terms of pulling back fossil fuel emissions. Now, why this is very important is we don't want to push the climate system over tipping points. In other words, tipping points are where you suddenly get a change in the climate system, there's no going back. And with 2 to 4 degrees warming, the West Antarctic ice sheet melts. With 1 to 2, Greenland melts, but that's over several centuries. We're almost there at the moment with Greenland. If another half to 2 degrees, you lose the Arctic sea ice. Well, we're virtually there. 3 to 5 degrees, in the boreal forest, which there are a lot of in Siberia and in North America, Canadian areas, you get pine beetle surviving and dieback occurring. Continental glaciers, glaciers like ours, 1 to 3 degrees. So people have worked out to keep the climate system safe, you need to have carbon dioxide in the order of 350 parts per million. And that's where the 354 came from. So what about future climate? Well, by 2030s, and Nelson figures, area figures are roughly the same, it's 1 degree warmer with less frost. 2090 is about 2 degrees warmer. In terms of changes in precipitation, this is the projected annual mean change in precipitation in the 2030s for Nelson, a little bit wetter, and maybe in the 2090s wetter in this part of New Zealand, though there's a bit of variance in that information. I think the clearer information is it will warm. I'll skip that, as I said. I left my Nelson figures, but I've told you them anyway. In terms of drought, these colours show you the incidence of a 1 in 20 year drought, what it changes to. And Nelson Tasman district, a 1 in 20 year drought becomes a 1 in 10 year drought. So the drought frequency doubles. This is in terms of agriculture drought, important for horticulture. The sea level story has probably changed a lot since 2007. The last science that went into the IPCC 2007 report was done around 2005. In the 2007 report, they didn't really take account for the melting occurring in Greenland and Antarctica. 2008 was the International Polar Year. There was a huge amount of research done on what was happening in Greenland and Antarctica, and the information, satellite-based information, uncovered there was a lot of ice melt going on, and as a result, sea level rise estimates have changed significantly in the last 3 years. IPCC talked about 20 to 80 centimetre rise. Here's the new science. The latest reviews have basically doubled that. So in other words, 40 to 160 centimetre sea level rise by 2100. And that's because the 2007 report didn't have what was the contributions from Greenland and Antarctica. So what does this mean for areas like the Tasman district? Well, if it's drier in summer, and I know irrigation is important for horticulture, that will mean more drought. But of course, if it warms up, it opens this area up in terms of cropping and horticultural activities for crops that usually like more heat. I think what's very important here is you have quite a lot of lower-lying areas around Maupuia, around Tasman Bay, and will be the implications of a 40 to 160 centimetre sea level rise, particularly not the actual rise, but when you have the storm surge with storms. And so this is where it's important to think about coastal inundation, erosion, loss of wetlands, beach erosion. The other thing which is important, when the climate is warmer, the atmosphere holds more moisture. Every degree it warms 6 to 8% more moisture in the atmosphere. So those northerly storms which dump, the rainfall intensity rises, so you get more flooding, so that's important for rural waterways, infrastructure, flood protection. So those are probably the important impacts. The other important impacts is you do have mountain areas here, and basically the native ecosystems get pushed up the mountains. So, in closing my part, I just want to say that I'll let you read this, but it's certainly, the science is very certain, it's well-developed, established science over 2 centuries, that more greenhouse gases, you warm the climate. And we've had a huge increase in greenhouse gases. You see that temperatures, all the evidence shows that global warming is happening. And this is a cartoon I got from Australia. I spent the summer at the University of Tasmania. Someone debating that they don't actually agree with global warming in Australia. And you can see there's Hercules holding up a flat earth. And there's just a cartoon of, well, something we don't want to see happen. I'll leave it there, thank you. And Richard will share 2 or 3 questions, then we'll swap to what. Yeah.
Well, thank you very much, Jim. We'll take 3 questions before we switch over, and then more at the end. Bruce?
Are you aware of the non-governmental international panel on climate change report, Climate Change Reconsidered, which came out in 2009?
Yes. Now, what I'd say is that what Ross Garneau says, when we look at science, it is by people who publish peer-reviewed science. And I think a lot of that material is not peer-reviewed science.
The difference strikes me is the folks in the non-governmental international panel appear not to conclude that it's man that's creating the difference to climate, that the Earth's climate has always been changing. And it strikes me that the difference is that they're not getting paid by the IPCC or the UN. And that the IPCC are coming to very political conclusions.
Yes, I'll answer that. I spent 3, and I'm not being paid now to be here, so I'll make that clear. I spent 3.5 decades researching climate, and for a lot of that time I was employed by the New Zealand Met Service and the then NIWA, looking at seasonal climate prediction and whole lots of other things, but certainly the IPCC work we did, we weren't paid by IPCC, it was part of our job. So,
No, sorry.
And I haven't finished. The other thing is, sure, over geological time, climate has varied hugely, and carbon dioxides were very much higher, say 70 million years ago. But the point I make is the world was a different place 70 million years ago. We're dealing with human civilization, agrarian societies, which have been around 10,000 years. So that is the relevant time period I'm concerned with.
Tony, at the back.
I think the science is unequivocal and appreciate it coming down. A couple of questions. The projections that you got into the future, are they based on not reaching a tipping point? And what are the projections if we do reach a tipping point?
Oh, okay. So really the future projections are based on scenarios, and that's really they're basically essentially what will happen to greenhouse gas